Hi, microphone testing. You hear me, right? Fine. Is there any pointer or how I can control the presentation? Okay, good morning, everyone. Thank you for coming. As Jiří introduced me, my name is Milan, and I am CEO of let's say, a young company which is focusing on the delivering solution for industry positioning. Today I prepared speech and talk about the topic which is well known at the meetings and on the forums. We deal with the industry solutions with the focus on the production industry. My speech is about how we can leverage the industry positioning technology to enable phenomenon which is called Industry 4.0, which rised in Germany 2013, and I will try to focus on revolution in active RFID system, which we are focusing on in our company. So let's start with some terms and introduction. What actually is the vision of the Industry 4.0 and what is all the about? Actually, term Industry 4.0 refer to early stage or further development for industries where the products are finding their way through the production process, and imagine in the intelligent factories and in, let's say, in the intelligent in the industries of the futures. Products, let me check the laser. Products and machines are going to communicate each other, cooperate driving the production. So the vision of phenomenon of Industry 4.0 is to build up the highly flexible and resource-friendly massive production, which will be in the future able to reflect the demanding and the hungry markets which is coming. Let me start from the history because if I'm talking about some revolution which is called Industry 4.0, it should be mentioned why 4.0 and what is before. So let me start from the history. It was mid 18th century where the first time and intelligent usage of hydropower was introduced, and such utilization revolutionized the production. So it was in that time, it was revolution industry 1.0. At the end of the 19th century, there is first conveyor in the production in the industry, and also there started some division of the labor work. So this stage we can call industry 2.0. After computers coming, and in the mid of 1970, the first computers are driving the labors, are driving the conveyors, and with the objective to speed up the production process. So there is a massive introduction and implementation of the electronics and IT to achieve the goal in order to speed up and to achieve the massive production in the production industries. And here coming to Industry 4.0, using the cyber physical systems, using the IoT, using the data stream and data mining to achieve the vision of Industry 4.0. I mean that all the products and machines are going to communicate each other to build up that highly flexible and resource-friendly massive production. However, as industry vendors and partners saying, the Industry 4.0 is still the vision, and it come to the real within next 20 years. So it's expected that in 2030 there's gonna be the cyber physical systems which control all the components in the factory. And Industry 4.0 is that topic what I still will repeat during my talk. Take a look what components generally build up the factory of the future. Actually, those are already known operation system or enhanced software agents, which allows you to proceed to provide advanced analytics. I mean, just analytics of the processes which are taking care inside of the production process. Those are also the intelligent machines, which are able to reflect the proximity condition and just demanding condition from the management team, for example. It's also virtualization and digital collaboration. I mean, everything's going to be virtual in order to reflect the heterogeneous environment of the machines and architectures and infrastructures in the industry. So those are all requirements on components which are well known, and you can often read about such components, and you can hear about such research over such components and topics on several conferences dealing with the evolution of the industry. On the other hand, we cannot come to the Industry 4.0 if we have no communication and if we have no data, because somebody needs to process the data. Those blue blocks are able to process the data, but we need something which are going to generate data and which is going to process the data. So that's why I just try to distinguish these two set of blocks with the colors, and because our, let's say, company cover is green. I use the green because this is actually what we are doing in our startup, in our company. We are building up just IoT and RFID systems to go to the industry and to allow machines, products, and operators talk each other, to cooperatively driving production. So without sensor-based extraction of operational data and without smart work pieces, which embeds some operational memory, no intelligent, no communication, and no data storage is enabled in the industry. So everything is about just well-known term which is called Internet of Things, Internet of Everything, Internet of Services, and true or not, this is just RFID. Everybody's talking it is IoT, but most of solution of IoT is just poor RFID systems. Doesn't matter if we are talking about the passive RFID system or if we are talking about the active RFID system, is just radio frequency communication. And in the future, all the components in the smart factory or in the factory of the future will talk just wirelessly, because there is a mobile fashion in the industry, because everybody will be integrated or involved in the IoT revolution. So how we actually my speech was about just leveraging industry positioning to enable Industry 4.0 revolution in active RFID system. Nowadays, some companies, we can say lots of companies dealing with offering, developing, and just delivering solution which is called active RFID. I mean some components which are active. It means wireless components which communicates thanks to the batteries integrated inside. I mean just object. I mean the product can communicate itself without any launching of any operation, because it's a battery and it is active RFID system. Passive RFID system, it's necessary to induce the passive tag in order to report with some ID identification or some sensory data. So nowadays we are here. all the, I don't know any automotive logistic warehouse which doesn't use any kind of the RFID system. We can talk about the access system. We can talk about intelligent inventory system. Everywhere you can find some kind of the RFID system. But just the main task of nowadays, 2015, RFID system is about the identification. Just to go with the reader or receiver, go close to the products and read some information. It works, and it's very good business, and it's market needed because you can do inventory. You can see how the product is moving when you take it, where is it, when you can read the information safe in the products, because it's not just only identification. There can be some sensory data stored in such product or in such tech which is embedded on the product. But nowadays it's not enough to come to Industry 4.0. We need to leverage all the features of nowadays active RFID system to come to industry positioning system, because it's topic of my talk, because it's a big part or significant part of factories of the future. Because without knowledge where the product is, where the worker is, or where the resources are, I mean for forklifts, I mean the automatic guided vehicles, I mean the robots, I mean the tools, laptops and measurement tools. We cannot move forward towards the Industry 4.0. So when that missing part to get to the industry positioning system is the ranging. I mean to take benefit of the signal, to process it, somehow process it, and to get information about how far the product is from you, how far the product is from the reader. I mean, the ranging, from my point of view, the ranging, why I use the ranging, in my case, the ranging is the distance measurement. And this is the point. And this is also, to be honest, this is also the point of our company. We do just distance measurement with active RFID system. And I show you why and how we leverage and how we benefit from such feature. So what we did in the Savio, that we just integrated two systems together, active RFID systems, which is embedded with some kind of system which is able to do ranging, and we are delivering for the production and for the factories so-called industry positioning system. Here is, I mentioned in the previous slide, I mentioned abbreviation which was called ultra wideband. Maybe some of you know, some not. Let me do some introduction. What is ultra wideband, which we used in our products? We do not build products on the nowadays technologies such like Wi-Fi, Zigbee, Bluetooth, WiMAX, ISA 111A and WiMAX. We just went further and just try to integrate, just try to develop solution or just radio RFID technology which brings something more, I mean something beside identification, and that what is the beside is that ranging and industry positioning feature. Ultra wideband technology is not anything else, just common standard from IEEE, which is referred to IEEE 802.50.4 Amendment A. Do you know just 15.4 is Zigbee? There is amendment from 2007 which defines application of different radios on the physical layer. Not narrowband radios, but absolutely ultra wideband radios with the channel width of 500 megahertz. This width of the channel allow for this radio to transmit very short signals with the length of 2 nanoseconds. So if you imagine you have the channel with the width of the 500 megahertz, you divide it, you have the signals, you have the pulses, which is the width of the 2 nanoseconds. And what is it good for? I will come to the benefits and advantage of such solution later on, but let me come back to some definition or maybe some parameters of ultra-wideband radios. It communicates in the gigahertz bands. I mean, starting from 3.2 gigahertz, going over to 4 to 7, up to 10 gigahertz band. And if you compare just classical narrow band signals, which you can find in your Wi-Fi, in your laptop, in your microwave, in your DECT phone, the channel of such ultra-wideband technology is more than 20 times wider. And because of there is some spectral density need, I mean, just we need to comply with some legislation. So we cannot go, or just not we, just ultra-wideband technology cannot go higher or on the same power level as nowadays narrowband communication technologies are. So power level of ultra-wideband technology is under noise in order to comply with the spectral density legislation or requirements. That's why you cannot interfere. The Wi-Fi, if you can compare, you can communicate in the maybe you can go to the band where the Wi-Fi or microwave or DECT phone communicate, but if you go to the under the noise, you cannot interfere. Also, this generally this standard was not released to build up localization. It was not released to build up the ranging. It was released to have some low power solution which enables to have high data rate. And that's true because if you imagine you have 2 nanosecond impulses, where you can get with the data rate. So there is not 638 megabit per second. This is 38 megabit per second. So this is 6 megabits. So there are 4 data rates which are defined in the standard ICUMT2015.4a, which starting from 110 kilobit per second, which equals Zigbee. We can go up to 1 megabits. We can go to 6 megabits, up to 27 megabits per second. And such technology or such standards has some really beneficial feature. It's not just only about the high data rates, but since it really transmits very short 2 nanosecond impulses, and if you are able to process such impulses, and if you are able to separate and to filter the first one, you are still ensured that you are receiving the direct one, not reflection. I mean, you are receiving the direct one. I mean, if you have some transmitter, active ultra-wideband transmitter, and you have some receiver, you are able precisely measure the distance between 2 components, between 2 devices, and this is the distance between transmitter and receiver. So ultra-wideband really enables to process and to perform precise distance measurement, which does not rely on the RSSI, I mean signal strength or power level, which is affected by the moving person, temperature, and obstacles, but just to enable real-time location systems or the industry positioning, or just to perform the ranging, you cannot rely to the parameters which are easily affected by the proximity environment, but you need to rely on some technology or principle which measure the time of flight. So how, when the signal just left from the transmitter and when you receive it on the antenna on the receiver's antenna, you know the timestamp, you do some averaging filtering, and using time of flight or TDOA approaches, you can really go to the you can build up wireless meter. You can take it to your pocket. You can put the active transmitter somewhere at the end of the room. You can take the receiver here or the laptop, and you know the precise distance. Actually, if we build up the company at such idea, we already can have the customers. For example, one funny story: we had a customer in Russia which built up based on our components systems for for building up the trees. I mean, just to making the holes in the exact position without using any tape meter, any laser ranger, just using two guys are going to the wood and just putting there the new trees on the exact position. So, and I don't want to tell that we just invented something new, because who invented the tape meter was not Savio, was not any company. It was the Alien fellow which comes with the idea. It should be fine to have such tool which is able to measure distance easily. So it was the Alien fellow which invented tape meter in 1868. And what we did in Savio, that we took his idea and to transfer it to the IoT manner, I mean to the wireless expression, not using any tape, because we are not restricted with the length of the tape, but we are restricted with the distance reading of such two components. And right now, just coming idea, okay, right now, somebody have the wireless ranging, have some wireless meter, and how to enhance such idea or such product to make a business, to go to the market. It's all of you who's doing research knows something like this, you know, just classical GPS principle: trilateration, multilateration, triangulation. It means once you are able precisely measure distance between two components, once you do it 3 times or 4 times, you can get the exact position of any active transmitter within the space. And that is finally idea. This is finally the product which is able to do business, and with such product you can go to the market. And this is really the principle how nowadays RTLS systems, I mean the real-time location system, works. Just imagine right now you are thinking about, okay, fine, I am talking here about, that's perfect, very good idea to make a business with the positioning system. It means who you can locate. You can locate your wife going to shopping, not to going somewhere else. Lots of customers ask me when I am introducing our products, okay, that's fine. And I know that about 50% of my meetings are finishing with the question, okay, that's a very nice product, and can I locate my wife? Because it could be very handy. Okay, I know, but you have the iPhone, you can track her. So don't use the ultra wideband or a Savio solution. So okay, let's switch from the introduction part, and let's come to take a look to the market and some use cases where such, let's say we can say such simple idea of the ranging can be transformed to the really market use cases. Imagine that you have the production hall. This is just simple production hall where the receivers, you can see the image of or just figure of the receivers mounted on the ceiling or on the walls. This is not a dust. This is not a problem of the projector. Those are active RFID transmitters installed and deployed on the objects in the automotive hall. And right now, just coming my favorite picture, which is showing where we can apply industry positioning systems. I like this time when I can stand here and to show that our products can be used in at least 7 parallel tasks. If you have just one if you have one installation in the automotive hall, you can solve 7 parallel tasks with one infrastructure. Just what is necessary to have as many active tags, as many active RFID systems, as many objects you want to track, as many objects you want to localize or navigate. I can start. I will stand within this slide, I think 5 minutes. I like to start from the left, where just imagine that you can localize the forklift and you can localize the pedestrian working in the automotive hall. What you get? Safety system. You know, just the driver knows where the pedestrian is, and I am not claiming that we are able to stop the forklift, because we are not producer of the forklift, but we can install to the forklift some industry tablet which just report the position of the pedestrian passing around, And we can tell driver, hey, be aware, there gonna be pedestrian, just enter from the shelf, behind the shelf, within 5 seconds. You should slow down. And even there are already such technologies or solutions which, for example, Linde is big producer of the logistic vehicles, shelves, and solutions, and it uses the active RFID tags mounted in the floor. And once the forklift pass this active RFID tag and the just active reader just reads such information, it means I am at the end of the shelf. I should slow down because there can be some pedestrian. So the first use case is you have a very nice safety system. Second one, I am coming to this side of the presentation. Just put the active tag to the product, and you know absolute position or relative position within the whole. It means what is it good for? You are manager of the shift, and you are asked to provide information how many minutes takes to finish the production of such car or such products. Once you click into the tablet, you click into the website, and you know thanks to the data mining and thanks to the location positioning system that, for example, this car will be done within 22 minutes because each tact has absolute time to be finished. And if I am talking about just precise and absolute time, I'm talking about the seconds. This car will not be in this tact more than 2 second deviation or variation because the products are still going to the conveyor. So you know how the product is going. It was the second one. Third one, I don't know if you have the experience from the production halls, mostly from the automotive halls. Nowadays, for the delivering spare parts over the automotive, they're using AGV vehicles. It is automatic guided vehicles, which have some trolleys, which just deliver the small parts to the operators, which should be mounted to the car. Nowadays, you come to the assembly hall, and everywhere you see the magnetic stripes, which are used to navigate the AGV vehicles across the hall. And just if you want to change the track of such AGV, you need to put the strip out with the hammer, and you put the new metal or magnetic strip somewhere else. It takes 1-2 days to relocalize or renavigate all such robots or such AGV across the hall. So, but using industrial positioning system, forget the magnetic stripes, because what you can do, you can define in the control system simply waypoints. It is just XYZ coordinates where the AGV vehicle should go. So again, it helps. It's just objective and benefit of such task is again to speed up the process. I mean, just you don't need to put the magnetic stripes away. You just sit to your computer and just set up new waypoints in the hall. Okay. The fourth one. Just imagine that you invested $1 million to buy the new forklifts for your 5 assembly halls. And what you need to know is how often the forklifts go, where the forklift is, and who operate with the forklift. Everything can be known again using industrial positioning system. I know that nowadays all the forklifts has the motor hours. You are aware about precise information, how many hours and how many meters each forklift passed, but use case and just queries from our customers saying to find out one forklift in our industry area can take 30 minutes because operator take the radio and asking all the operators, forklift operators in the proximity of the hall where the forklift is, and John answering, hey, forklift is probably that forklift I forgot in the assembly hall M3. Okay, that operator goes to the hall, didn't find because he just was missed out, and it can take 30 minutes to find it. Just imagine even if you save 30 minutes per day for such automotive hall or automotive producer. I cannot transfer the time to money because I'm not producer. I don't know what are the charges and what is the budget for one day, but 30 minutes per one day is a lot. The fifth one, we are claiming that we are able to produce the zero fault tools. I mean, zero fault mean the tools which will not produce any fault. I mean not the tool itself, but I mean the operator which operates or which handles with such tool. Because imagine again situation. You have the bell, you have the conveyor, where two types of different cars are assembling. You have two types of drilling tool, which should for example to drill some holes or just maybe to work with some screw. For example, once you take the tool which is not correct and you go closer to such products which is not authorized with such tool, again we are not talking here about the industry positioning system. We are talking about simple ranging. You are coming quite close to such car, but you are not right tool. So and since thanks using ultra wideband technology, you are able precisely measure distance. So it means if once you get about at 1 meter distance to such car, you are able to remotely switch off the tool. And once you get far, you can turn it off. And it's not your task; it's task of such tool which simple control the battery regarding the distance. This was the fifth one. I'm going to last two. Entrance and exit management of some zones. Just imagine very nice situation. We have three teams in the automotive hall. We have teams of blue guys, yellow guys, and red guys. And the blue guy is not allowed to enter to the zone which is authorized just only for the red guys, because he has not such level of certification, authorization, doesn't matter what, but he should not enter here. He doesn't know there is no physical fence. This red area are just only coordinates in MySQL database, for example. Because what is zone management about? Is about the comparing the actual position of the pedestrian or the worker with the position of the zone which management defined it. So once the blue guy entered to the not authorized zone, the management of the factory can be notified, the log can be saved, even the Twitter or Facebook state can be changed. So everything is up to customer how he want to reflect such situation. And everybody knows, and you can read it in the newspapers, you can hear it in the news, in the television, you can read it on the Facebook even, that the drones, mostly nowadays when we have some migration issues, the drones are going to be often used. It's already got to its mature state. And when I was just talking with one guy from the automotive industry, he told me innovation equals drones. The drones going to do not most of the task, but just significant part of the task of the operators and of the robots. So I am happy that I can claim that we are trying to be first company, at least in Czech Republic, which will be able within 6 months able to navigate drones under the roof, inside of the hall, without any control, just using only industry positioning systems. Nowadays, maybe you will laugh, but just the big automotive producers, I think that Volkswagen will take a look at this as well, mostly because of nowadays situation with Volkswagen. But some automotives and partners just wish to have the small drones equipped with the cameras and laser meter to do automated inventory tasks. I mean, just you can imagine that you have the pallets which are stocked in the columns, and simply if you are able to navigate the drones over the columns of the pallets, you can simply, by measuring the reflection of the laser, you can simply calculate of the pallets, and you can do it 10 times per day without any operator. That's shame. I know operator has no job, but it's Industry 4.0. Okay, just continue with the. Okay, it was the just 7 use cases which we are reflecting in our company, which we are able to provide customer with. So, and also it was the guy Lord Kelvin which claimed that if you cannot measure it, you cannot improve it. And what we doing in company, we are measuring. And what we are measuring is the distance passed, is the positioning. And once we know how often the resources goes, how fast it goes, and where are they stored and where are they forgotten, we can say to customer or everybody who is using industry positioning system, hey, your forklift is in the hole M3. So don't search for it, go directly there. So if you can measure, for example, where the forklift is, you can improve the production process. You can save the time. It means you can save the money. Okay, another use case. I think it's quite easy and simple to imagine after that slide from the automotive, where everywhere you can use industry positioning system. Logistic, lots of products. Okay, navigation of the forklifts. There should be from your side maybe some at the end of the talk the question. It's not possible. It's not possible to use active RFID system or your system to monitor the position of the boxes, of the paper boxes within the warehouse, within the logistic, because just imagine that you will install active transmitter per each box. It costs something, so it will not work because logistic and warehouse has more than thousands, 10,000 of products in the shelves. So you cannot do it in that way. What we are doing is combination of passive RFID with active RFID. I mean, imagine that you will take the passive RFID stamp, just put it to each paper box. The price for passive RFID tags is about 10 cents or maybe 5 cents with antenna integrated inside. So how we can transfer such task or situation for the logistic? Forget to install active transmitter per each box. You can just simply stamp each passive RFID to per paper box, and if you want to have just a real time or maybe history information, how the products in the box right here just move over the time, what you can simply do is to localize that object, that guy or that forklift who operate with the box, because you have the passive tag on the box, you have the active reader from Motorola, for example, on the forklift. Once they get connected each other, there is an event start to localize. So I mean, we can start to log, somebody's moving with the box, somebody's moving with the product, start to localize who is moving with the product. So you don't need to localize thousands and thousands of boxes or products. You have to localize that operator or that forklift who's decided to take this product out. And once the connection is lost, I mean just connection between the passive RFID and the reader, this is the event, stop localize, and lock it to the MySQL database, because it means the product finished here. So it's necessary to think in that way, that the active RFID is not solution for all use cases, but you need to combine it with the passive RFID as well. So there are some use cases for the logistic and warehouse industry. I can start with the first one, precise navigation of the driver or maybe forklift itself to the exact spot in the shelf. I mean, no more searching for the label in the shelf where I should put the box. I should put it to the spot A, B, 625 and going around a shelf and just checking out where the position is. You can be navigated to such spot. Just the best science fiction is to not to drive, maybe to keep the forklift to do it itself, but it is the vision of next 20 years. So also the navigation of the forklift to place the product, or navigation in the corridor between the shelves itself, is the perfect task for industrial positioning system. And what is here is amazing use case. I mean, amazing already is just trying to use the drones to deliver just lightweight products within the warehouse. So it was not we who is going to be first to do it, but Amazon just came to idea, hey, drones gonna be everywhere. And just nowadays challenging in the drones research is, you know, it's just energy consumption. I mean, just lifetime of the drones. Also the possibility of the drones to take the heavy materials, because we have the partnership with the drones manufacturer here in the Brno, which has the big drones for the industry, and this drone is able to carry out the product or just the object with the weight of the 2 kilos and can fly. It cannot fly more than 10 minutes because of the batteries. Batteries must be integrated inside of the drone. So I think who nowadays starting to do research at the university or maybe somewhere in the company, anything around the drone can be camera processing, can be visualization, can be navigation, can be new composed materials for the drones, anything around the drones doing well. Another use case is the mining and construction industry. I mean, just imagine that I'm not talking here about the exact positioning. Here I am talking about the ranging. Just imagine that we are in the mining on the construction site, and you have the danger drilling machine, and we have the customer in Italy, which already using our system to protect the workers which are operating around such drilling machine. So what he's using is just simple the ranging system, which consists of the anchors which are installed over the machine, mostly around the danger part, which is rotating, and the active transmitter are assembled on the helmet of the labor. And it's really working, it's really using, it's really a real case which is implemented in the customers in Italy. So what you can do is simply measure distance from some parts of the danger machine to notify not the driver, but to notify machine itself. Don't work, stop, because somebody is quite close to you. You can hit him, you can kill him, for example. So in the mining construction industry, we are reflecting just the demands of the customers, not to localize the people, but to protect them. Because maybe you're asking, fine, can you make a business on the protecting the people? You can, because any injury in the production, in the construction, increase the price of such construction. It means every once per month, just coming guy, just checking out how many injuries just happened on the construction, and it's more injuries increase the price of such construction. I mean, just for example, mining task. And if you are able to reduce the number of injuries during the shift, you are able to decrease the money which you need to use for such construction. So again, it is about saving money. I am often using, when I'm talking with the customers, about quote which reflects and which introduce what we are doing in CVO. And I'm claiming that with CVO products we can save life and save money. It means, yes, we can save life, and even if we save life, we are saving money, because you don't need to invest so much money for the workers which working around the machines. So another use case, I think that it is the last one. Before I'm going to the last one, it is necessary to imagine that you have one product which is ready for industry positioning inside of the halls, under the roofs. I mean, it's not waterproof, it's not vibration resistant. So for such, I'm this is the small advertisement. For such companies, CVO developed a new solution which has IP67 protection to reflect the water outside. It has also the Ethernet bayonet locking, not allow people to throw out the Ethernet cable from the anchor. It is vibration resistant. We know it is because it's working more than 3 months in Italy, and each component has HTTP server integrated. It means you can go to your living room during evening when you're drinking wine. You can open your laptop, and if you have some internet connection at this space, you can connect to such anchor, which can be, for example, this anchor, and you can set up the new zones, and you can download the log from such anchor to see what happened during the time shift. And for example, you can reconfigure the diameter of each zone. Generally, defaultly, we deliver those mining anchors with 3 zones. We call it a notification zone, warning zone, and danger zone. And for each zone, you can remotely, through the HTTP command, you can set up the event, what should happen. I mean, if you are in the warning zone, maybe if you are in the notification zone, just machine should start light up. If you are in the warning zone, the machine should start, for example, start some horn to notify you are too close. If you are finally in the danger zone, the machine should stop the work. And it's not nothing sophisticated. It's just switching of the relay of the power cable. That's all, because you need to save the life of the operator. The last use case which I'm going to mention here is the entertainment, sport, and training centers, which leverage the benefits of the industry positioning system. It's not just army; it can be firemen, police, which has in each region some training center. And just imagine each soldier equipped with the active transmitter, just generate lots of information, which allows you to do statistics and just to know what was wrong during the training. You know how far you are from your colleague. You know if you just occupy just a room, and you know if all the rooms are occupied with the army guys. And it's not just about the coordination inside the training halls. It is also about the sports centers. We have one customer which built up the big center from the European money, which is the center of excellence for the health, style, and sport activities, which is using these systems for monitoring the behavior of the people or of the team member during the 30 minutes training. And we can show that that customer or that excellence center of the sports, how the members of the team behave during the training. Okay, that's some brief. I should slowly finish. Maybe if you will be provided with such presentation, I don't know, it's task too easy. I don't care. So you can read just about just common principle how this system works. You have some anchors, you have some tags, slave anchors, master anchors. Slave anchors just simply measure the distance from the active tags, pass such information to the master anchor. Master anchor just pass such information to embedded PC or server, which runnings the location engine, visualization, HTTP, MySQL, data filtering, and provide this information through the local LAN to the operator, which can using HTTP just monitor all situation real time in past, and is providing with the monitoring of the object, visualization, building management. It means he can build as many buildings as he need. He's doing control and data export. So this is the general principle how nowadays location positioning system works. We have for such scenario for automotive, we have solution which we called RTLS kit, which there are the anchors, there are the text. Maybe you cannot see because they are black, and the customers are provided with solution which is easy for installation and which is able to cover 2,000 meters square, and they can do it by itself within 1 hour. So as we know, I don't want to claim that we are doing something especially unique, because there is a concurrency in the world which mostly doesn't rely on the ultra wideband technology, but rely on the Bluetooth. You know, all of you have the Bluetooth, and the nowadays smartphones has a Bluetooth version 4, which is the low power Bluetooth. low power region Bluetooth, which allows you to, let's say, somehow measure distance to devices, which is called iBeacon. Go to Google, check iBeacon. You can order it, and if you can do absolutely same task as we do with the ultra wideband system, you can deploy all the iBeacons over the hall, and using your phones with the Bluetooth technology enabled, you can see position of your mobile phone, but with the accuracy of 2-3 meters. We know it today. This year, the Ampere 2015 Brno has lots of use cases and lots of companies showing the Bluetooth application for customers for phones, and we were in the testing with them as well, and we know that the precision of all the technologies which relies on the signal strength, Bluetooth, Wi-Fi, any else, cannot go so precisely as the time of flight, which is using by the ultra wideband. So what is the most important parameters which customer asking for the industry positioning system is, first of all, it is quick installation. You cannot install this room more than 2 hours. We know just lots of companies in the world, and we are working with them. I don't want directly, but we have their products, and we know that, for example, such hall are going to be installed within half of a day, because they rely on the, for example, algorithms using angle of arrival, which requires quite sophisticated calibration on site. So, and it requires hours for calibration. So precision. Sometimes, and in most application, 10 centimeters, 20 centimeters is not necessary. You should go under half of meter to be ready for market. Stability, yes, minimum deviation. Once you take the tech and you put it to the table, there should be no deviation in the positioning calculation. You can solve it with the accelerometer integrated, and we do it. It means once I am moving, I'm localizing. Still, I'm localizing. Once I will come to this table, the accelerometer, for example, right now stop to work. It means stop to localize, and don't consume any energy because I am not moving. So minimum cables, yes, you have the old industry halls and assembling halls. You should invest minimum money to install new Ethernet cables. Customization, the company should be able to provide customization, and also the reasonable price, because yes, it is a must. I know we are finishing of time. I have some YouTube videos showing our products, but just download it. It is on YouTube. So let me summarize the last 2 slides of my talk, my first keynote talk in my life. Thank you. And it's about, I think that yes, there's going to be a revolution in Industry 4.0 in next 20 years, but I think that everybody can be part of such a revolution, because you don't need to invent anything absolutely unique, and you don't need to invent the wheel. Because, for example, in the case of our company, which still starting, I don't know if we are able to survive more than 2 years, I'm not sure. But for example, in our case, it was just such idea. It is just only well-applied tape meter, which was done wirelessly. And once we do it many times, we do multi-iteration and industry positioning. Thank you for your attention.
Thank you, Milan. It was really interesting. It's really nice to see how actually technologies which academia has been working on are really applied in industry and can really work. So thank you again, and some questions.
Thank you. Only one question. In the case of the commando you show us, those men with guns, what do you think? Is it possible to join your technology with guns so that they will shoot only on the target which will not be equipped by your technology?
Actually, for such tasks you need to have some quite precise technology. Just if you are asking if we are able to equip the gun,
yeah.
Just try to repeat the question because I didn't catch it.
Okay, so you are my enemy.
Uh-huh.
You are my enemy.
Okay, fine.
And beside you is friend.
Okay.
And I mistakenly point to the friend and shot. In that case, I expect that this gun will not shoot because this friend is equipped by the broadcasting device. And if I will point to you and will shoot, then I will kill you because you have not this device. Is it possible in future?
I think in future everything is possible, but for such case the laser will work the best, because if you have some laser, I don't think so if using the radio technology is a good idea, because it's radio, it's signal which is passing through the air, and nowadays it's, I don't know, and within 10 years it's quite challenging to get to the such precision, to go to the centimeter precision, because for example if I'm standing here and I'm your enemy, your friend is standing here, it's still 30 centimeters and there is an error of 30 centimeters nowadays. So yes, I think it can be a good idea, but let's do research.
Yeah, thanks.
Thank you. Another question? Actually, I have one. Can you mention what are the main kind of issues which you are facing when you are deploying your solution in some kind of automotive hall or some such a scenario?
Yeah, if I should be concrete in case of our company, the distances. I mean, just for example, making business with the industry positioning system, it means providing installation, not just product, just buy product on the eShop and just install the automotive hall. You need to go to that customer. You need to see the space. You need to see the hall. You need to spend hours and hours of talking with the management, what they need and how the hall looks like. After you need to provide the quotation or just architecture. You need to go there again to discuss, and I think that issues the time and the distance you need to pass to communicate with the customer. But it's not so challenging. But I think the most challenging that the most significant challenges for us, any customer is the same. That's the issue, because you can have the Škoda, Hyundai, Tatra, Fiat, TPCA in the Kolín. I was there and I saw each automotive hall is quite different. More tubes, more forklifts, and you cannot have one unique and unified solution for each vendor. So you need to go there and you need to discuss and you need to install in any different manner. So it's not about unified product, because it still requires some customization for any customer.
Thank you.
Thank you very much for your talk. In fact, coming after this question, I would like to ask you about interference and how your system is tolerant for interference and how can you measure it. Thank you.
Yeah. Actually, interference means how our installation process starts, or just how starts our process of communication with the customer is to asking, okay, it's fine that you want to install it. Our system operates from 3 to 6 gigahertz in the 4 channels. And the first question is, do you have some system operating here in such band? He told, no, I don't think so. Talking with the IT guy, no, we have nothing here. You coming to another IT guy, or maybe you open your smartphone or laptop where you have some analyzer or sniffer. You see 5 gigahertz Wi-Fi operating there. So that's the issue, which is not challenging, because since we are operating at 3 channels, which can be remotely configured, we know, for example, that 5 gigahertz Wi-Fi is operating in the proximity. We can go to the 3 gigahertz, and even since we are operating under noise level, so we are not so issued with the interferences from the Wi-Fi bands, because what we are doing, we are just filtering the noise, just taking the ultraviolet signal from the noise. So up to now, after our 1.5, which company running, we were not issued with the interference at any customer. Or if your question was how we measure it, today we just have some tools which is able to monitor just spectrum utilization or application, and that's first what we are doing. Okay, if you are using 5 gigahertz radios, we go to the 3 gigahertz. Okay, that's all.
Okay, and even with the equipment in the workshop, so anything that is coming from welding, from mechanical structures, anything, this doesn't affect your system or the accuracy of your system?
Actually, if you are talking about the mechanical parts or issues, yes, everything what smell with the metal. I'm sorry for using the word smell, but it is radio. We don't like the metal. because if I see that I'm going to install the anchor and there is some metal tube which can reflect the signal, we have to install it somewhere else, because what is the condition to be really so precise? To have the line of sight. It's after we can guarantee we are going to provide you with a sub-meter precision. But if you do not provide with line of sight condition, okay, let's talk about sub-meter and higher precision.
Okay, so there is one. Okay.
So there is quite a lot of research which was done the past years on Wi-Fi indoor localization. Can you relate what you just presented to it?
Yeah, you know, I did my PhD on the localization using Wi-Fi and Zigbee and all such radio technologies, and nowadays fingerprinting is a well-known method to use such radios like Wi-Fi and Zigbee, and I think that you can use even the industry Wi-Fi standard to do the positioning, and such companies, for example, not IBeacon, but Bspoon, just to take a look on the Bspoon company, Bspoon.com, using the Wi-Fi, and they are able to do the positioning localization, but with the accuracy of the let's say meter, maybe 2 meters. But what we are reflecting with our solution is the demand of customers for low energy devices. Just compare consumption of the Wi-Fi chip and compare the consumption of the ultra-wideband chip, which is defined by ICUMT2015 which was defined with the focus on the low energy consumption. So Wi-Fi is fine. It can work for such application like monitoring of the, for example, to search the forklift or to monitoring the behavior of a forklift. You don't need to have the precision 50 centimeters. You need to know if the forklift went by this corridor or by this corridor, so you can use the Wi-Fi. Sure, but I don't think that the Wi-Fi. I do not consider Wi-Fi as our competitor. I consider as the alternative solution to our products. Thank you.
Okay. Any other question? Okay. If not, thank you again, Milan. Thank you very much.
Thank you.
So, let me close this morning keynote session. So, thank you very much for coming. And now, basically, the lunch is served in the hotel restaurant, and the afternoon session will start at 1 p.m. in the smaller meeting rooms. We have plenty of very interesting papers, so you are very welcome to join us as well. Thank you.